Good morning, everyone. Hello and welcome to the Country on Stage South Korea program. My name is Jason Palmer, a journalist at The Economist and a longtime writer about material science and technology. It's very good to see everyone back in the room after a couple of shaky years. This is not my first time at JEC World, not even my first time hosting this session, which I did 1 year and 1 week ago today. And it is really good to see some familiar faces and very exciting to see some new faces. This is an 85-minute session dedicated to Aero-Mobility in South Korea and its light-weighted future. The clue is in the name. It's all about lightweight materials, their applications to aero-mobility, and how all of that contributes to environmental sustainability. We'll be going through some successful examples of lightweight carbon composite materials in South Korea with some of the country's most renowned experts, and with thanks to KCARBON for hosting and developing the session. Just to tell you a little bit about how it's all going to work, there will be a couple of introductory remarks. We'll then have 5 short presentations. I'll be joined shortly by our distinguished panel. And then we will have questions at the end. So do save your questions for then. If we save some time, if our speakers are disciplined about their timekeeping and I help them keep on track, then we'll have time for all of your questions. So the first thing for me to do then is to introduce our distinguished panel, if I may. So if I can call to the stage, please, Yoon Cho, the Managing Director of Hankook Carbon, please do come up. Chi-Hoon Chae, Executive Vice President and Chief Technology Officer of Hanwha Advanced Material Company. Sung-Wook Jung, VP at Hyosung Advanced Materials Corporation. Chong-Soo James Park, Vice Chairman, Kukdo Chemical. Min-Hwan Song, Senior Manager of the Korea Aerospace Industries. Let's give them all a round of applause, shall we? Now, I was just at, as it happens, the Smithsonian Air and Space Museum last week, where they have the original 1903 Wright brothers flyer. Which is an amazing thing to see in person. But what I noticed was before the Wright brothers were making planes, they were making bicycles. And I saw one of the original Wright brothers bicycles. And it's amazing how much lightweighting was already going on when they were just in the business of making bikes. Just very elegant design, in particular the cutouts of the main sprocket. This was all the same machinery that went into the very first plane, the chain and the sprockets and the whole business. Lightweighting was on their minds from the very start. The very latest technology was being put to use in aero-mobility from the very start of aviation. So this morning we're going to hear about the very latest technology from some heavy hitters of South Korean industry. But before all of that, let's start with some introductory remarks. In the first instance, I should tell you again, this session is sponsored by Korea Carbon Industry Promotion Agency, a government agency under the Republic of Korea's Ministry of Trade. Since 2021 has been fostering carbon industries in the country with particular expertise in what we're here to hear about today. So for our first opening remark, I'm very pleased to welcome the president of KCARBON, Yoon Hyuk-bong.
Good morning. I'm sorry. I am back at JEC World after a few years, maybe 5 years ago. I'm very happy to participate in big parties of composite industries. First of all, thank you to everyone and the members who prepared this event today. Especially, I would like to express my gratitude to Chair Jae-chul, the Ambassador of the Republic of Korea, and also I can find Eric Zhang, Chairman of JEC Group. Yeah, many people know that Korea has been continuously growing with a lot of effort for a long time to develop the composite industry and also has various cooperative relationships with many global partners. So I would like to thank JEC Group once again for being at the center of our relationships. You know that the world is deeply challenged by global environment problems, and carbon neutrality has become an absolutely important keyword in all industries. Along the various composite industries, the carbon hybrid composite industries has played a very important role in achieving carbon neutrality through weight reduction. And I'm confident that it will make an even greater contribution in the future. Also, the growth of the carbon composite market is expected to grow faster, and especially in the field of aerospace and mobility, which is the core topic of today's country on stage. I hope that this time will be a good opportunity to understand the present and the future of the aero-mobility related to carbon industry of South Korea. Thank you again to speakers as experts in the composite field. And I hope that all of you have a great time in beautiful Paris. Thank you.
Right. Thank you, Dr. Bonk. Now, for a couple of brief congratulatory remarks, it's a deep honor and a pleasure to welcome the South Korean ambassador to France, Jae Cheol-che. Please join us.
Good morning, bonjour, Mr. Bang Yoon-hyuk, President of K-World, KCARBON, honorable guests, ladies and gentlemen. On behalf of the Korean government, I am pleased to deliver the congratulatory remarks at the opening of Country on Stage Korea Conference on the occasion of the JEC World 2023. I wish to welcome you all who have joined this morning's session. As you are well aware, JEC World annual event serves an excellent platform for major players in the industry of composite materials to share their experiences and lessons learned. Today's topic addresses multifaceted challenges facing us. The carbon industry has been a significant contributor to global economic growth while impacting on our climate system. Material innovation has been an important factor in the growth of industries and the creation of the new industries, while triggering urgent need for a circular economy. Carbon composite, the symbol of material technology innovation, has been widely used in various fields such as aerospace, automobile, architecture, and energy. Their demand will be rapidly increased and extended in coming days for various reasons. The upcoming commercialization of aero-mobility, like urban air mobility or UAM, is one of the shining examples of the material technology innovation. Many experts forecast that global carbon composite market will be more than quadrupled by 2030. Korean companies have made significant progress in technology independence in general carbon composite materials in the relatively short time period. There are, however, considerable technology gaps in the field of high-performance carbon composite. The Korean government announced a strategy to promote and strengthen the competitiveness of carbon composite last year and provide necessary support for research and development, human resource development, funding, and overseas marketing. My embassy continues to support the Korean companies' entry to French and European market by working together with the relevant Korean agencies. Before concluding, ladies and gentlemen, I wish to share with you Korean government bid to host the 2030 World Expo in Busan. Korean government is making every effort in partnership with the private sector to get the 2030 World Expo in Busan. Our theme is transforming our world, navigating toward a better future. It addresses common global challenges facing humanity. Korean government will pursue global solutions in collaboration with all BIE member countries by organizing the 2030 World Expo in Busan. Our export theme will be evolved on following three pillars: sustainable living with nature, technology for humanity, platform for caring and sharing. I believe these issues concern your industry. You have an important role to play in our endeavor. Your engagement and support for the World Expo in Busan will be highly appreciated. I hope this event will lead to great success through exchanging your invaluable best practice and insight. Thank you very much for your kind attention and excellent journey. Merci.
Thank you, Mr. Choi. Now, onward, the last of our introductory remarks. We're going to hear from an expert who hails from Jeonbuk, which is called the Carbon Fiber Valley of South Korea. Our speaker is head of the carbon bio industry in the province. Please welcome to the stage Ji-hyung Lee.
It's such a pleasure to meet you all. I'm Lee Ji-hyung, leading the carbon industry division at the Jeollabuk-do provincial government south of Korea. I am very delighted to take part in the JEC World 2023, the world's largest composite materials exhibition. And let me express my gratitude to the JEC Group for organizing this event. Jeollabuk has been investing in infrastructure and R&D for the carbon composite industry for 16 years, with the belief that it will be a key source of future income for South Korea. Such efforts have resulted in developing carbon fibers with high strength and high modulus that can be applied to the space and aviation product. Now, we have sourced technologies competitive enough in the global market. On top of that, we have been exploring overseas market for years, linking companies and innovation institutions. This is to strengthen the competitiveness of local companies in overseas market and find the sales channels of carbon composite product. Believing that today's fair is also the opportunity to find new markets abroad. You are going to observe the exhibition carefully and closely, hoping that the JEC World Paris will continue to energize those engaged in this field. I would like to thank the JEC Group members again for making this event happen. Thank you.
Thank you very much, Mr. Lee. Okay, time to move on to the presentations. There will be 12 minutes each. Again, please save your questions for after the session. I would encourage you to keep to your sort of 12 minutes, but these things always run out of hand, so there is always the chance, we hope, to speak also after, to exchange ideas, do some networking at the South Korea Pavilion. But for now, our first presentation is from Sung-Wook Jung, who since 2021 has been at Hyosung Advanced Materials Corporation, and he'll be telling us about the first high-performance carbon fiber developed in South Korea, Tansum. Thank you, Mr. Jung.
Good morning, everybody. My name is Sung-Wook Jung. I am in charge of sales and marketing for carbon fiber and aramid fiber at Hyosung Advanced Materials Corporation. I'm really honored to be here to present on behalf of Hyosung, which is sole Korean carbon manufacturing company. Today, I will introduce about Hyosung and its carbon fiber business. Okay, first of all, I'd like to start with introducing the history of Hyosung Group. Hyosung Group was founded in 1966 with the development of nylon yarn and has expanded its business to various business areas such as chemical, construction, and heavy industries. Although the history of the carbon fiber manufacturing is relatively short, the reason why Hyosung is operating this business quite well is the company's earlier understanding for fiber and chemical industries. Hyosung Group consists of one holding company and 4 operating companies. Hyosung Advanced Material Corporation, which I belong to, produces various industrial materials, which will be explained in detail next slide. Hyosung TNC is engaged in fiber manufacturing such as nylon, polyester, and spandex. Hyosung Chemical produces various chemical products, including polypropylene. Hyosung Heavy Industries is producing heavy industrial products such as power transformers. Hyosung Advanced Materials, which I belong to, produces Hyosung Advanced Materials Corporation has a motto of "We assure human safety and comfort through optimized advanced materials." It has 5 business divisions. The reinforcement division makes tire cord made of polyester and steel. Technical yarn division produces high-strength industrial yarn. Global safety yarn textile produces airbag fabrics and cushions. Interior division manufactures carpet products for vehicles. Carbon aramid division, which I belong to, is dealing with carbon fiber and aramid fiber businesses. This division is the newest one in the company, but is also the fastest growing division as well. Regarding the sustainability for the company, the following examples will represent Hyosung's major activities. Please report to them if you have any interest. Okay, from now on, I'd like to talk about Hyosung carbon fiber products, Tensum. Tensum is the brand name of Hyosung carbon fiber. It's a combination of tan and something, which implies that people can make something special or something extraordinary with using Hyosung's carbon fiber products. Now, I will explain the brief history of Tensum. Hyosung began its R&D in 2008 and developed H2550, a high-performance performance standard modular product and precursor simultaneously within 2 years by our own technologies. In 2012, the company developed HC3555, an intermediate precursor and carbon fiber by our own technology also. In 2013, it started the commercial production of 2,000 ton plant in Jeonju, South Korea. And it has increased its capacity to 9,000 ton as of today. In addition to this, the company is going to start a new plant in China early next year. The capacity of China plant is 5,000 ton for 2 production lines. The company's global capacity in 2028 is supposed to reach 24,000 ton per year. Now, the company has 2 types of products, a standard modulus product and an intermediate modulus product, respectively. The detailed characteristics of the products can be shown in the table. The main feature of the standard modulus product is its high tensile strength. For example, in the field of high pressure vessel application, it has received a lot of positive feedbacks from many customers, and it is growing its sales rapidly for this application. Hyosung is on its way to expand its product portfolio. In 2019, the company developed an unsized product for thermoplastic composites. And last year, developed a high-strength intermediate modulus product H3065 in collaboration with Korean academic institutions. The H3065 is a high-strength intermediate modulus product. This was developed through the collaboration of industry, university, institution. Various institutions and universities such as KAIST, KIST, KCARBON, Jeonju University, and Hanban University were involved in the development of each function. Hyosung took the lead to develop the precursor and carbon fiber, while other domestic institutions and universities were mainly in charge of carbon fiber analysis and processed products related aspects. Okay, let me briefly introduce the target properties of the high modulus product line. The company plans to cover the modulus range from 325 to 430 gigapascal and aims for the strength up to 7 gigapascal. Once the development is complete, the company will proceed with the promotion accordingly. While the company basically focuses on developing carbon fiber for aerospace applications, it is currently also working on developing resins and prepregs. The primary goal is to develop resin systems that meet aerospace requirements. Furthermore, it plans to evaluate composite material properties through the over-molding of high toughness prepregs. This slide shows the quality management systems that the company is currently securing, including IATF 16949 related to the automotive industry and AS 9100, which is related to the quality system for aviation. This is a photo of our production site in Jeonju, South Korea. The company is currently operating up to 4 lines. As you see on the right side of the picture, it already secured additional expansion site where 6 additional production lines can be potentially added in the future. Okay. This is the last slide I prepared for. To sum up key points, Hyosung Advanced Materials Corporation will continue to expand production to meet the growth of carbon fiber demand, including the aerospace mobility sector. From a product line perspective, the company will establish high-performance grades that meet the demands of the aerospace industry, and will further develop advanced materials such as resins and prepregs. The company will continue to collaboration with a number of institutes and universities, and we will make effort to supply not only the Korean local market, but also major overseas aerospace companies. Thank you. Thank you for your patience.
Thank you very much, Mr. Jung. Next, we'll be hearing from Chong-Soo Park, who's been at Kukdo Chemical for 40 years. Now he's vice chairman of one of the largest epoxy resin companies in the world. And sustainable high-performance epoxy resins is exactly what he's here to talk about today. Dr. Park.
Good morning, everyone. Actually, last year I gave the speech as chairman of KCARBON, which is Korea Carbon and Nano Industry Association. Today, I will give some presentation regarding the high performance and sustainability of epoxy resin for aerospace industries. Epoxy resins has been used for long years, since 1960s. Recently, including electric vehicle and aerospaces, aircraft, launch vehicle, they are using carbon composite. So today, recently the composite market, there are 2 important issues about high performance and sustainability. High performance means heat resistance or the very low temperature resistance or micro crack. And sustainability means like recycling, and also regarding the environment issues, we are looking for some biochemicals, bioepoxies. So today, I'm focusing on these 2 directions. This is a simple introduction about Kukdo. Kukdo is one of the biggest epoxy resin manufacturers since 1972. I joined in 1983, so this year is 40 years anniversary. I was a chemist in 1983 when I was 25 years old. And for many years, I was running director and president of the company, and I'm a vice chairman of the group. And Kukdo doing the manufacturing epoxies and curatives and reactive diluents and catalysts. So regarding composite market also, we are supplying resin and hardeners, and reactive diluents. Kukdo has 4 factories in Korea, and also we have 2 overseas manufacturing sites, 2 factories in China and 1 factory in India. So regarding aerospaces, why they use epoxies for composites for aerospaces? Because of environmental issues and longer lifespan, sustainability advantages. So today's regarding the composite market for aerospaces, what kind of epoxy we are supplying and what kind of development we are doing. Of course, for epoxy resin for the aerospaces, we are supplying bis A type and bis F type, but in many cases, because of heat resistance or mechanical properties, high performance requirements, we are supplying this kind of high performance epoxy resin means like the amino epoxies, multi-noble-lux, and toughened epoxies. And also we are supplying as a system. System means resin with some additives or reactive diluents as a system, resin part and hardened parts. And also regarding sustainabilities, we are focusing on the bio, we call green composite for aerospaces, for the interior side and the structure side. We are developing new chemistries, not BPA-based one, not petrochemical, bio-based epoxy resins. And also, we have responsibilities about recycling. So recyclable epoxy we are developing. So this is most popular grade for the structure part of aerospaces, tetraglycerol diamino diphenyl-methane. It has very high heat resistance, and we have 2 different grades, like distilled materials of these amino epoxies. So as you can see, the structures, it has very high heat resistance. And this is 3-functional, we call the triglyceride paraminophenol and the meta-aminophenol. We have Aero-5 and Aero-8, these 2 grades. Also, popularly they are using for this kind of products. And also we are developing and supplying the market multifunctional noble-lux resins, mostly for heat resistance and high mechanical properties. So bisphenol A noble-lux epoxies or bisphenol F-based noble-lux epoxies, multifunctional, you can have easily more than 200 degrees Fahrenheit, Celsius of the heat resistance, high TG purpose. And also, this is the multifunctional noble-lux system. We are manufacturing of this noble-lux resin for our internal captive use. So we can design many different type of noble-lux resin, like a multifunctional or BPA noble-lux, this kind of things. And for aerospaces, not only heat resistance or the very cold, low temperature resistance, many cases we need micro crack resistance. So we have to have toughened epoxy. To reach that toughened properties, we can modify with rubbers, silicone, or the coaxial materials. So as you can see, viscosity and the portion of the toughened materials, we have different properties we can have. Details, if you have questions after my speech, you can ask me separately. And recently, the aerospace area, the aircraft, they want to have the mass productions. In the past, aircraft, they're mind of the cost, but they're competing to make a low cost, fast manufacturing. So they used to do the many different process, but recently, not pre-preg, autoclave. They want to do fast track, fast curing with RTM, resin transfer molding system. So we are introducing the market for the resin truss molding for structure part of the aircraft. So this RTM system providing high mechanical properties and fast curing and high heat resistance, as you can see, like that. And this is the evaluation result and the process how we can have. Now we talk about sustainabilities. So carbon neutral, and every country has some national net zero committees, and Korea also following that. And Kukdo trying to make it bio-based epoxies and recyclable systems. So as you can see, glycerin-based ECH we call partly bio epoxies or 100% bio epoxies. We are supplying in the market, especially in Spain, in Europe, like in France, we are supplying our customers, important customers, for this kind of bio epoxies to make a sports boat or some other composite materials. And also for aerospaces, we are trying to make it with the infusion system or prepreg system based on these bio epoxies. And our target for bio epoxies by 2025, 100% bio system, which means not petrochemical epoxies. So already for wind braid, some wind energies we are supplying and being evaluating with our system, bio contents around 45%. You don't need to change cure conditions, or you can have high performance cured properties without difficulties. So Kukdo recycling, now the carbon composite or glass fiber composite is being used for many applications. And now like wind energies, wind braid, after 25 years we have the concern about recycling. So we want to have easy and low cost recycling system based on different chemistries, 100% bio, self-degradable epoxy systems, but which has good enough mechanical properties. So now Kukdo introducing in the market for sustainabilities, bio-based epoxies, and developing bio-based epoxies. And then we are developing co-development with a university, and there is a company, KCTech in Korea. They are very strong in the recycling technologies. So we are introducing self-degradable or bio-based epoxy, which is easy to decomposite, and then they are developing the process. So we have the facility company technology of the process and the new chemistry. We can have a very good sustainable epoxy system. If you want to have some trial for bio-based one, I believe at this moment we don't have a mass production, but from this year, from September, we are going to start the production of mass production of the bio epoxy 100%, and we are recommending for any applications. You don't need to use that bio epoxy 100%. You can mix with BCA based plus bio epoxy. Then you can have a very good performance with sustainability. Thank you for your listening. Thank you for your attention.
Dr. Park, thank you very much. Moving on, our next speaker is Yoonho Cho, Managing Director of Hankook Carbon, the largest producer of composite intermediates in South Korea. And he'll be telling us about how just such an intermediate composites company fits into a sustainable aero-mobility future.
Hello, thank you. I'm honored to speak at this forum today. Our company is called Hankook Carbon, and we're the smallest company, I think, out of the all five here today. And I'm not sure how much innovation we can bring to the table, but we wanted to explain, as an intermediate materials company, we are responsible for realizing lots of biofibers or bio-based epoxy resin that we just heard from Gupta, but to make it into a product and being reliable and responsible for the quality of that product, our responsibility is to accelerate the existing technologies and bring innovations together. So here we go. We have been established since 1984, and over 38 years of experience in Korea. Our strength has been focused on developing niche markets and specialty carbon prepregs within Korea. So even though our company is small, we've had vast experience in working with different applications in different industries. Even though during COVID we've been struck hard, financially we expect to forecast nearly $350 million this year. So we're seeing some post-pandemic market drive. We have 9 plants in Korea and in Vietnam and in Slovakia, with representative offices in China and Germany and UK. Our business areas has been focused in automotive, aerospace, sports and leisure, and construction energy carriers, and electronics. Again, we're a very small company, but we are in very different and big industries. We're here talking about future aero-mobility, and one of the core functions of what we see in the future is bringing different aspects of industries together. For instance, UAM, urban air mobility, we're seeing lots of technologies that we would expect to use in automotive industry, but using aerospace qualifications and certified method of production. Our core technologies is coming from weaving and impregnating the fabrics, whether it be UD or NCF or a plain weave. And then how to manufacture these intermediate materials, whether it be RTM, PCM, autoclaving. We have our own in-house facility, not because we want to be involved in all methods of production, but because we needed to accelerate and get fast feedback on what is the limitations of what we can do at different method of production. So I have a picture here today from Hyundai. I know we're working with Hana, who's going to talk to you later, but we are in many different governmental R&D programs thanks to the support of the Korean government in this industry. We have identified some of the major parts where composites can be used in UAM, and structurally is the most obvious one. Lightweight, high strength profiles is required, but also mass production capability will be a key for us. And that's where we see lots of press compression molding kind of technologies can be used. Secondly, propeller blades. It needs to have low noise. As you know, weight balancing and structural durability are all core functions that we see is going to be crucial in future. And battery structure is also, a lot of eVTOLs are considered to be the most interesting sort of method of transportation in future air mobility, but we have not seen any kind of qualification requirements in this field in terms of how to house these batteries, how we're going to cool down the batteries, whether it will be fire retardant enough to keep major safety issues for the passengers. Regarding this aspect, for structural parts, we are using epoxy-based prepreg with high toughness and high TG. It is under validation at the moment, but we believe that this will be ready in market within coming years. Flexible cure methods is something that we are also working on, B3HT. It's a type of prepreg where we can have different staged curing cycles. For interior parts, we're actually a Boeing certified supplier for interiors. We already have AS900 and we are listed on QPL, and we're supplying phenolic-based prepreg for aerospace industries. This is a concept of fast curing for us. We believe that in order to cope against metallic-based structures, we need to be able to cure and manufacture parts within minutes. And this is where our technology, we hope, can see in being used in UAM industry. So our target curing time is to be under 4 minutes for all cycles of prepreg. Flame retardancy, again, I think, will be a more and more important factor in this industry. As you see, a lot of electric cars are becoming an issue with flammability. And we think this will also be the same for urban air mobility. And we're bringing the fast cure resin system with the high flammability resistance. And these are the 4 main products that we have in line. The FC9 XL series has been awarded the JC Innovation Awards in 2020, but we have yet to have actually used this application in an actual product. We're still in R&D phases, but we think by the end of this year, we'll have some good news and we'll see actual product realization within this year. This is common sandwich structure panels, but again, I put this into this presentation because you cannot have one perfect composite material that can serve all functions. And we want to be a composite company that can supply multi-function, multi-material sandwich structures for press compression molding technologies. Internally, we have an engineer of nearly 70 to 90 people out of 550. So we're investing 15% of our HR into engineering. And one of the core functions that we're investing is how to realize from prepreg to an actual product. And through government programs and through collaboration with companies, our strength is in developing the iron bird is actual iron birds and thrust test rigs to test what is the optimal power pack solution for UAMs. So with ground electricity and with inverters and motors, we would develop a prototype of a propeller blade, and then through optimization and finding what is the perfect RPM for this motor, what is a good shape or structurally what kind of propeller that we need is our core strength. So we're currently involved in 4 different kind of programs. One is the optionally piloted personal air vehicle, which is doing a flight test right now with our material and our propeller. With LIG, we're developing a 200 kilogram cargo drone. Another government program that's led by us, we're developing a 150 kilowatt class power pack solution, and we're evaluating that power pack. And finally, for sustainability, there's very limited things that we can do as an intermediate company. We believe that what we can do right now is being ready for the future. And how we can be ready for the future is, as mentioned, being in the industry of automotive for the mass production, being in the existing aerospace industry for the qualification and certifications and providing the quality. And then thirdly, how to make our company environmentally friendly. One of our efforts in doing so is making we're using 40% of all our electricity consumage through solar panels. It is already been established, and we're constantly checking our life cycle carbon footprint, and we're investing in how to recycle our used carbon prepreg and extracting the carbon fiber from a finished product. A bio-based material, thanks to Gukdo and other flax fibers, we're constantly testing it, and we have a product of a prepreg using fast cure for flax series. And finally, I want to say we have a new R&D facility in Kimpo area, which is 10 minutes from the Kimpo airport and about 35 minutes from Incheon airport. But we believe this one-stop shop facility where we can collaborate together with lots of different companies in the world to develop from TRL level 1 to level 6. And we want to be the one-stop solution for prototyping from materials to an actual product. And we hope this will be the proving ground for new sustainable composites. I tried to keep my presentation short, but I hope it isn't too short. If you have any more questions, feel free to visit us at N22 at Hall 5. Thank you.
You will not get any complaints from me about short presentations. It's such a rare problem to have. Thank you very much. Next up, we're going to hear from an expert from Hanwha Advanced Materials Company. Polymer scientist and engineer Chi Hoon Choi is Hanwha's executive vice president and CTO, and will be telling us a bit about what the company's been up to in its work on mobility.
Good morning, ladies and gentlemen. I'm honored to be here with you today at Conference Stage Korea. I'd like to give you a short introduction of Hanwha Advanced Material, and then talk about recent developments in my company. The headquarters and the R&D center is located in Korea, and we have 2 domestic manufacturing plants and 6 overseas manufacturing plants, 1 in Europe, 1 in China, 4 in the United States. And there are 2 business centers, 1 in Europe and 1 in the United States. We are going to put some more sites in foreign countries. I think Hanwha Advanced Material is a unique company who can supply not only intermediate materials, but also molded parts. This slide shows product portfolio in my company. We have glass mat reinforced polypropylene and chopped fiber lofted reinforced lightweight reinforced thermoplastic LWRT, and expanded polypropylene, TPO and TPU sheet, and a thermoset 1 sheet molding compound. Lastly, we can supply continuous fiber reinforced polypropylene and polyamide. We are now trying to make another kind of other kinds of materials. I think I'll have a chance to introduce something other in the future. Based on the various kinds of material technology, we have developed various processing technologies in our global plants. And I think Hanwha has outstanding strengths in the field of compression molding. So you can see, for example, GMT compression molded rear bumper beam and front stiffener and seat back. And you can also supply LWRT based headliner and the body on the cover and luggage board and so on. We are now trying to find out some new applications with a cost-competitive solution. The other area on which we are focused is solar materials, such as ethylene vinyl acetate, EVA sheet for solar cell encapsulation, and polyester type backsheet. We have a close partnership with QCell. It's a module maker. It would invest $2.5 billion to build solar power manufacturing value chains in the United States. So we are also invest something in the USA to expand our manufacturing capacity. From now on, I'd like to share some information about our ongoing project. Let's get down to something new. The first one is composite parts for electric vehicles. We have many things to make battery upper and lower cases based on existing platform. That means it can be used for ICE vehicles and electric vehicles. So you can see complex shape, battery upper cover. It means due to the limited design capability. So we selected a conventional SMC, chopped glass fiber with unsaturated polyester. As a molding technology for this kind of vehicles. Recently, there are some car OEMs who adopting their unique skateboard platform. That makes us to develop a high impact toughness SMC. So we developed a hybrid concept. That means the combination of short fiber reinforced SMC to obtain processability with woven fabric reinforcement to improve impact toughness, to protect external shocks during the driving. Recently, we are going to produce Kia EV9, and we are talking about some more project with Hyundai and Kia. The second one is fairing parts for eVTOL. There's a need to make a nacelle of XP1 butterfly from over-air component in the United States. We tried to use vacuum bag only curing process instead of autoclave technology to reduce the part cost and to reduce the investment cost. If you want to see the nacelle prototype, please visit our booth in the Hall 6. We tried to optimize the processing condition to make that kind of a big part. It was not easy to optimize the temperature and time, and so on. But we could make the right manufacturing process. The next one is about 3D printed parts for satellite. We are co-working with SatTrack-I, a high-resolution imaging satellite maker headquartered in Korea. We want to use carbon fiber reinforced PEC, polyester ketokaton. We tried to use dual nozzle 3D printing, followed by compression molding to minimize deep patch. It's a small but very high performance part, so we tried to use 3D printing technology instead of autoclave. The last one is pultruded part for solar module. There was a demand from our customer to replace aluminum frame instead of with composite one. We made the decision to apply pultrusion as a molding technology because it can form a continuous fiber reinforced three-dimensional profile. We considered polyurethane as a base material instead of epoxy to reduce the material cost. And we also considered closed injection box to get a better impregnation of glass fiber during the process. We optimized the shape and thickness based on the FEA simulation and some expansion analysis results. Recently we got a feedback from our customer that the composite applied module passed all kinds of engineering specification, including including wind pressure, snow pressure, and flammability test, and so on. I look around current Hanwha's business areas and some ongoing projects. What will be the most acceptable technology for the future mobilities? In my opinion, there will be a new opportunity for composite researchers and engineers interested in purpose-built vehicle and advanced air mobilities. I think above mentioned technologies, SMC and VBO, 3D printing, or pultrusion technology will be the good candidate for the future mobilities. I summarized all kinds of processing technology that Hanwha have developed or Hanwha is trying to develop in this slide. It seems there are two categories divided into automotive industry and aerospace industry. However, I think it is going to be below and get to mixed in the near future. The last one I'd like to say to you is that Hanwha has accumulated experience about some plastic composite material and some set composite materials. and all kinds of processing technologies. We are ready to have open discussion with all of you. Thank you for listening. Thank you.
Thank you very much, Mr. Choi. Now, it's almost time for the questions, which I hope you've been saving up. We're going to try to squeeze some in towards the end, but there is one final presentation, and that honor goes to a senior manager at Korea Aerospace Industries. Min Hwan Song has been thinking about this stuff for 25 years, from small civilian aircraft to fighter jets, and we're going to hear a bit about what he's thinking about as it goes commercial aircraft. Please.
Nice to meet you. I'm Min Hwan Song, just introduced. I'm working in KAI, and I'm very happy to introduce KAI's composite R&D program for next generation commercial aircraft. In this presentation, next generation means the high-rate composite manufacturing technology. My contents today have 5 topics. First one is thermoplastic fuselage assembly, and third one is resin fusion process for a large wing skin string assembly and torsion box. Fourth one is SQRTM, same qualified resin transfer molding process to make a torsion box. I think these 4 kinds of technology is very competitive to make a high production rate with the current, compared to the current technology with the autoclave and pre-prep technology. KI targets to make more than 60 aircraft per month with equivalent quality and cost. The last one is material qualification. For the thermoplastic technology, KI wants to implement the whole fuselage structure with the thermoplastic materials. We selected LMPEG material with a unidirectional tape. For the large skin, we selected AFP machine to lay up large controlled skin and oven consolidation, not autoclave consolidation. For a long stringer, we selected continuous compression molding process, and for a smaller, relatively smaller kinds of parts, such as frame and clips, we applied the stamping process. And also eco-friendly manufacturing technology, we invite recycled materials to make window frame. And finally, we are conducting induction welding process and resistance welding process to whole final assembly. You can see the final part configuration, which has 3 meter by 2 meter size. We finished the TRP, technology readiness part, in 2021 successfully. This program is ongoing process, and end of this year, this program will be finished. This slide shows the skin manufacturing process. We selected 4-inch tape, and the AFP speed is 0.5 meter per second. And you can see the bagging process and oven consolidation process. And we selected and we conducted C-scan to scan internal defect and 3D scanning to check the final part design and the dimension and tolerance. We also conducted a destructive test to check inside of the part quality, and DSC tests also were conducted to check the existence of cold crystallinity. This is a CCM machine to make a stringer, having head section stringer. We conducted 5 volume and void volume tests, and we accept the minimum percentage of void volume, and also dimension tests and DSC tests also conducted, and C-scan also conducted. We spent many times to check the optimum temperature and time pressure, and we finally got the optimal press window currently. For the frame and clip manufacturing process, we used 2 kinds of press. Bigger one is 400-ton press, 2 meter by 1 meter bed size. Smaller one is 100-ton, size is 0.5 meter by 0.5 meter. Two presses have IR heaters to give high temperature just before applying pressure. KI is developing several kinds of configuration, such as frame, stabilizer, double-bolted clip, and long clip, and L-shape. The difference between from the previous technology is we used unidirectional tape, not fabric, pre-prep. We conducted destructive tests and non-destructive tests to check the internal defect and the quality issues, and the void volume and DMA tests also conducted. Most of the results are within our expectation. As I mentioned, the eco-friendly manufacturing technology, we shredded and crushed the previously consolidated parts to make approximately 1-inch fiber-length recycled material, and we added extra resin pellet to give a more viscosity when you heat the temperature to make a mix. And finally, we got a 30% fire volume window frame, and currently to give the more structural reinforcement, we are starting to give pristine same pre-preg material over the window frame structure. This is assembly development process. We're developing induction welding with a speed of 0.3 meter per minute, and resistant welding, weld long clip to skin. We successfully completed 1 meter by 1.3 meter TRP parts successfully 2021. And also we conducted NDI inspection to check the bond drying quality and single lab shear strength test to check the mechanical property. Our target is to make minimum 8% of co-consolidated parts mechanical properties. This part development program also completed within this year. I hope to explain with the real this final assembly in next time. Second one is wing skin stringer module in KAI. We selected high tape unidirectional dry tape material, which is 0.25 quarter-inch unidirectional tape, and the resin system is RTM6-2. For the large skin, we laid up with the ALP machine, and for the stringer, after lay up with the ALP machine and hot ray forming process to make L-shaped tie. We also conducted TRP parts in the 2021. You can see the final part size, 4.1 meter by 1.5 meter with some controlled parts. This slide shows manufacturing process. The AP machine speed was 0.6 meter per second. You can see the high ray forming pictures. The difference between previous one is the relatively lower temperature hot ray forming, which means 120 degrees Celsius hot ray forming compared to the 170 or 60 degrees Celsius hot ray forming. And this also will be completed at the end of this year. Currently, we finished the final parts manufacturing assembly tools, and we are nearly completed the preform manufacturing for the large wing skin and stringer. Third topic is torsion box to make with the resin infusion system. The main difference from the previous large wing skin stringer module process, we selected QSO material system, which means 3 different layers weaved as one layer. It means 0 degree, 6 degree, and -6 degrees layup as one ply. You can see the part size, right-hand side roll area of the picture. 5.3 meter and 0.9 meter size. This is a one-piece torsion box. we displayed this actual part in the JAC Asian show in the past. This slide shows the SQRTM process. We selected Hexply 8552 prepreg material, which is plane wave system. We demonstrate 1.2 meter by 0.4 meter demonstration parts, and also we applied expanded copper foil to protect lightning strike. This is also one-piece torsion box. We conducted every mechanical physical test after completing the parts and during the parts manufacturing process window. And the most of output and results are within our expectation. This is the last page, material qualification. Korea has the material qualification approving system from government. This is very important to applicants because previously applicants can only submit material qualification during the type certification submission. But currently, we can apply the material qualification issues to the government side. KI submitted 3 kinds of material system to government side, and actually we approved PCD of a material manufacturer side in the past, actually last year. And currently we are developing material test to make material allowable generation. Thank you for your attention, and I appreciate all participating companies to efforts to make this successful demonstration part technology with the KI. Thanks.
Dr. Song, thank you very much. I think what we'll have to do now is called a question speed round. Does anyone have a burning question they have been waiting all of this time to ask? Raise your hand. I'm told there are microphones that will be going around. Anyone? Is everyone very shy because it's very early in the conference? Everyone wants to talk to you later, privately. I'm reluctant to start a brand new topic with just one question on my sort of the prerogative of the presenter. So I will speak to you separately. We will go ahead and call that at the end of the session because, as everybody knows, JEC is an extremely well-planned, it's relentless, frankly. So we will let you get on with what is next. I should tell you about the next session hosted by Solvay about composite battery solutions. But for the moment, can we thank all of our speakers from today, both on stage and those off? Thank you very much. I would encourage you all to visit our speakers at the South Korea Pavilion, and I would wish you a good rest of the JEC. Thank you very much.